Hello, I welcome you all to this another interesting screencast. The problem reads that the projectile is launched with a velocity v naught. Determine the range r and the maximum height h attained and the time of flight. Express the result in terms of the angle theta, and we know the acceleration due to gravity is g. Right, so this problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. Some basics: we have velocity, which is the time derivative of position. We have acceleration, which is the time derivative of velocity. From the two, we make dt subject to formula. We'll have a ds, v dv. All right. From these three kinematic equations, we can develop a couple of equations depending on the boundary condition, but we do have this common one where acceleration is equal to 0. Acceleration is constant at t equal to 0, and we have additional boundary condition v naught and s naught. And from this we can derive the following equation: s is equal to s naught plus v naught t plus half act squared. Then we have v is equal to v naught plus act, and then we have v squared is equal to v naught squared plus 2ac minus s naught. Okay, right, so here we are going to have two components. We'll have one component like so, and then we'll have another component like so, right? And also here, these are the same levels. When you have this point, if it is at the same point as the start point, then we have also additional information that we know. So let me just explain that information. All right, so at this point here, this is it has some initial velocity at this point. So this is b. Let's call this b. So we call this vb, and then we call this vbx, which will be equal to v naught x. Okay, this one is vby, which will be equal to v naught y, because they are at the same level, right? This level, they are at the same level, then we expect the same result. Okay, then this one here is v naught x, which is equal to v naught sine theta. This is v naught y, which is v naught cos theta. All right, so let's imagine this is our theta b here. All right, this is our theta b here. Therefore, this theta b here will be equal to, at this particular point, it will be equal to theta. Okay, is that fine? Okay, so let's begin to work. All right, so v naught and theta in this case are known, okay, as variables, but they are known. All right, so let's start the work. So let's start with this formula here. What do we have? Of course, v naught and theta are known, so we can use this. We'll use this later on. We'll come and use this, okay, on the same part. So let's start with vertical motion, and we are using the equation s is equal to s naught plus v naught t plus half act squared, and our s in our case is equal to is equal to 0. We are using 0, and s naught is equal to 0 also, and then we have ac, which is equal to minus G. Right. So with this we can say 0 is equal to V naught is equal to V naught Y, which is equal to V naught sine theta. Therefore, this is just going to be equal to V naught sine theta times T minus half G T squared. Writing this, we can write this as T. We factor out this, and minus half GT. Therefore, our T is just going to be equal to 0, and our other T will be equal to 2 V naught sine theta divided by G. Okay, so we can simply say the time of light is equal to T is equal to 2V sine theta divided by G. Alright, we can also use V naught, V equal to V naught ACT to find T. Again, we are using vertical motion. So let's do that. We want to try out the same using this equation. So here we know that our V is equal to final is equal to VBY, which is equal to VOY, and we say this is equal to V naught sine theta, right? This is equal to, because they are at the same level like so, so we expect the same, right? You can check out this and prove this. Then we know that our AC is just equal to minus G, and our V naught is just also equal to, this one I just need to indicate to say it's a minus, this is a minus, this is minus, okay, minus, okay, let me just write this. So this one is minus, so let me write this. So this is equal to minus VOY, which is equal to minus V sine theta. Right. And also here is minus. Let me just write this properly. This is minus VOY, which is equal to minus VO sine theta. And then V naught is just equal to VOX, which is just equal to V naught sine theta. Therefore, writing this, we are going to have minus V naught sine theta equal to V naught sine theta minus GT. And making T subject to a formula, this just becomes equal to T is equal to 2 VO sine theta divided by G, okay, which is similar to this one. Again, I just wanted to show to say you can use either that formula or the other one, right? So let's go to the second part. This is where we are being asked to find here, let me just indicate some of the properties. Here I expect Here we're going to have this component like so, and then this one like so. At this point, our V, let's call this as C. This point is C. So we call this Cx is equal to V naught X, and then this one VCY is just going to be equal to 0 at this point. Alright, so we want to find H. I can use this equation if I want to. So let's go ahead. So using V squared is equal to V naught squared minus 2AC S minus S naught to find H. Okay, and we are going to use vertical motion. Therefore, we have V itself, which is just VC y, and is equal to 0, and we have V naught, which is just equal to VOY, and is equal to VO sine theta, and then we have, of course, AC equal to minus G, and then we have S equal to H, and then S naught equal to 0. Then writing the whole lot of this, it's just going to be equal to 0 squared, which is just 0, is equal to V naught squared sine squared theta, okay, minus, right, let me put a plus here, the minus, there is a plus there, okay, so minus 2G in brackets H minus 0, okay. Right, which is just H. So let me just rub this. I just put H here. Okay. So with this, we can then simply say our H is just equal to V squared sine theta squared divided by 2G. But we know that we can replace this. We know that sine 2 theta is equal to sine 2 theta is equal to sine 2 theta. So we know that sine 2 theta is equal to 1 minus cos squared theta, and then we know that cos 2 theta is equal to cos squared theta minus sine squared theta, and making cos squared subject to a formula, this just becomes equal to cos 2 theta plus sine 2 squared. And then getting this, plugging it here we have sine 2 squared is equal to 1 minus what do we have? Sine squared minus, this is a G, this is minus cos squared there, we plug it, it becomes like so, and then minus sine squared theta. Okay, so taking it the other side, this can also be written as 2 sine squared theta equal to 1 cos squared 2 theta. Okay, and sine this is just going to be equal to 1 minus cos 2 theta divided by 2. So we can plug this here, for this part, right? You can plug it there. Okay, and when we do so, we're going to have the following. Let me just write this. We'll have the following. Where is it? So this is just going to be equal to v squared, v naught squared, and then we have 1 minus cos 2 theta, okay, divided by there's a 2 underneath there, so the 2 and the other 2 multiplies, then we have this. Okay, right? Is everything fine? I think so. Let me check. So we use this equation. We had v naught there, which is sine squared and so on, and did everything. All right, I think this is good. This is fine. So we found h, and therefore our h is just going to be equal to v naught squared 1 v naught squared, then we have 1 minus cos 2 theta, okay, divided by 4g. All right, so let's move on to finding r. So r, we are going to use this equation again. Okay, so using s equal to s naught plus v naught t plus half act squared to find the range r. Again, we are dealing with here horizontal motion. We are dealing with horizontal motion. So we have s here, which is equal to r, and then we have s naught, which is equal to 0. Then we are dealing with ac, which is equal to 0. Then v naught, which is just equal to v naught x, which is equal to v naught cos theta. So with this, we can say r is just equal to v naught cos theta times t. Okay, and we know that our t, we found our t as equal to 2v naught sine theta divided by g. So replacing this, we are going to have r equal to where we have t, so it just becomes a 2v naught squared sine theta cos theta divided by g. Okay, but we can write this. We know again that sine 2 theta is equal to, we want to replace this one here, seen this one. So we know 2 sine 2 theta is equal to 2 sine theta cos theta, and therefore sine theta cos theta is equal to sine 2 theta divided by 2. So using this, we want to plug in this, we want to plug in this one, we want to replace it there. Okay, it's in there. Okay, that's fine. So we know that sine theta cos theta is equal to sine 2 theta divided by 2. So replacing that there, we'll have r equal to v naught squared sine 2 theta divided by g. Okay, so I think this is really about it. So we found t, which is here. We found t in terms of theta and v naught and g, which is also here. We spent a little bit of time because we just had to use also the other equation. And then we also found r in terms of theta and v naught. Alright, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next sorry, I forgot to, we also were asked to find h, sorry. Okay, so I hope my video was helpful. Give me a like, continue sharing my channel. Bye bye, see you in my next screencast.